with one exception. The only difference between simplify and verify is verify has an equal sign. Verify has an answer. It tells you what you're supposed to have when you're done. That's the only difference. So instead of not knowing if you've simplified far enough, now you will when you reach what it tells you it should look like. So that's the only difference here. You're still using all the same properties and all that other stuff. It's just going to be, there's going to be an equal sign thrown in here. So you know where to stop. So let's verify this. If you remember, the easiest way to do these things is usually to work from left to right, a lot of times. Or you start with the most complicated side and try to make it look like the less complicated side. So I have secant squared theta minus 1 over secant squared theta. It is something else. You're something else, Nicole.
Huh. Yeah.
Who's Nicole?
Joe. So I get tangent squared. Now, anytime that I have to verify something, or anytime I've got a mixture of tangents and inverse functions, my best guess is that I want to try to rewrite everything I can in terms of sines and cosines. Because those are kind of the roots of all of these, okay? It's a little bit easier to work with. When I see division, I'm also going to split apart the fraction. So I'm going to write this as tangent squared times 1 over secant squared. Because each one of those fractions then can be rewritten with sines and cosines. What's tangent squared in terms of sines and cosines? Sine over cosine, but it's going to be sine squared over cosine squared. And what's 1 over secant squared as? It's cosine squared. And look what happens.
You got the science.
You're Catholic.
Thanks, smiley face.
Vaguely remember these as well?
Yeah, these are fine.
Okay. Combine fractions before you use identities. So there's the sad face, which means you have to get the common denominators. Okay? It is, but if you don't put theta in it, it's less work. Yes, ma'am.
Because at first he said he wasn't sure. It said approximate on the
Thank you, sir.
What did you do? There's a question.
So we need a common denominator. What's going to be the common denominator for 1 minus sine, 1 plus sine?
Square minus 1.
Just multiply them together. So you wind up with this. Fraction on the left needs the 1 plus sign. Fraction on the right needs the 1 minus sign. Denominator would have been multiplying those two together. If I FOIL that out, you guys notice how it's going to be a difference of squares? So it's 1 minus sine squared. Oh no, what is 1 plus 1?
2.
What is sine minus sine?
0.
0. So you get 2 over
Cosine.
squared. Hey, what's 2 over cosine squared? How can I rewrite that?
2 times secant squared.
And you're happy again.
A crying face will change that. Now there's Sterling Messi equals -1.
Okay.
So we got it out. So this last Let's just do our homework.
So we want to verify that tangent squared x plus 1 times quantity cosine squared x minus 1 equals negative tangent squared of x. So what they're putting here is they're putting in a couple of the trig identities to start with. And as you put the trig identities together to start with, well, what is tangent squared plus 1?
Secant.
Okay. Is that secant squared?
Yeah.
Okay.
Oh shoot.
So that's secant squared.
And then sine.
Careful.
Yeah.
Yeah, they are. Yeah. Because how do these things I want to isolate as what?
No, that was just directly right towards me. Yeah. You owe me
Now, careful with the next one. Negative sine squared, right? See, on the next one here, you have to be careful because if you look at this, the actual identity 1 minus cosine squared gets you sine squared. But in this case, you have to take out the -1 to start with. So you take out a -1, and then you can have 1 minus cosine squared. Because the identity is sine squared plus cosine squared is 1. So it's sine squared is 1 minus cosine squared. Since this is reversed of it, if you take out a -1, it changes the signs. Okay? That's how that one works. So you'll see those types of tricks thrown in here. So now you get -1 times secant squared theta sine squared theta. And they want us to equal tangent squared. Well, what's secant squared? 1 over cosine squared. So you just rewrite it. You get negative sine squared over cosine squared, which is da, da, da. You're happy again. You're happy and we clap your hands.
I wish no one clapped.
It's too late.
Hoppenworth enjoys math. No, he doesn't. He just thinks,
I just like clapping.
You enjoy it.
who doesn't like clapping?
I don't.
Hoppenworth enjoys my presence.
Oh, fight me. Oh.
My money's on Jana.
Same. I'll throw the fight.
Jenna would just pull out her softball bats.
Everybody always
Remember
says
these
that.
from last year when you had addition and you had to show multiplication?
No, friend.
Okay.
I probably don't actually.
Converting sines and cosines. All right. So take a look at what you're given to start with. You have a tangent and a cotangent, and you want it to equal a secant times cosecant.
Well, everything just.
What you want to try and do here is whenever you have addition problems turning into multiplication problems, it usually meant there was a common denominator thrown in and some simplifying. So you want to rewrite tangent and cotangent in terms of fractions via sine and cosine and get a common denominator. Very good. So when you start that, you have sine over cosine. In order to add fractions, you have to have a common denominator. So here, what's going to be the common denominator between a sine and a cosine? Sine and cosine. So I'm going to multiply them together. So I get a cosine and a sine. Fraction on the left needs a sine. Fraction on the right needs a. And what do you get?
1.
And what's 1 over cosine sine? You just flip them around. Oh, sorry.
Mr. Rogers, really quick, do you want to try to solve the no better than she
Yeah, like.
says? That's the only thing I found the no better.
You have a bearing problem.
Yes.
Oh, no card.
Well, I mean, they kind of.
Did we get both sides this time?
I get one side.
That wasn't funny.
Write it on the one side.
No, because you know why?
Just have anything.
Because if you write it down, it's going to force you to study.
Nothing.
Is it a plain bearing one?
All I'm saying. All I'm saying.
Is it a plain one?
I don't know. Maybe.
You should know.
I should. You're right. You're right. I should. But I'm not going to tell you.
You
All right.
should.
Well, it says there's 2, so there's probably one
I
plain one
remember
and one plain one.
It could be a
No,
car.
okay.
Would the car use the both
It
bearings?
could be a duck.
The duck would use the plane bearings because it has wings.
Shut up.
Do you do one of the problems
Tomorrow.
It has an
My plan is tomorrow to get everything back
To go
and do
every
that.
bearing.
Because this, I know there's 2 days worth of homework here. I'm just going to kind of go over as much of all this today and give you guys today and tomorrow to work on it. And spend time tomorrow talking about the bearing stuff. Okay?
All right. Oh.
What is the R and the L thing?
Go right
Right,
to left.
left.
Go right to left.
Do it right to left.
So in this case, sometimes going left to right doesn't get you anywhere. Bless you. If you have secant plus tangent, those guys both have the same denominator, 1 over cosine, sine over cosine. So it would have just been 1 plus sine over cosine. That really doesn't get you anywhere. Sometimes it might be more beneficial to work from right to left. It doesn't happen very often, but sometimes the more complicated stuff is on the right. Okay. Now, yesterday we did one that looks similar to that. And how did we get rid of the 1 minus sine in the denominator? You multiply by its conjugate. Okay. So we multiply by the conjugate. I'm going to get cosine times 1 plus sine all over 1 minus sine squared. we okay with that? Now, excuse me, this then becomes cosine 1 plus sine over what?
Square.
What simplifies? How many? Just one cosine simplifies now. So then you're left with 1 plus sine over cosine. And what's the trick when you have 2 on the top, 1 on the bottom? Split. So you split them apart. So you have 1 over cosine. And what's 1 over cosine? Secant. So you get secant plus tangent. And you are?
It's like a puzzle.
What'd you forget?
Hey, come see me when you're done.
Okay.
Okay, I'm in the middle of the quiz when you get done, so.
All right. Good luck. Good luck on your quiz. I know. I hope you pass.
He's a teacher, should not take my quiz. It just doesn't add up. I'm just gonna subtract myself in this situation.
Do your homework.
Okay.
Yeah, you can do it. That one's.